Hello, all of you. In this session, we are going to begin with the chapter Chemical Reactions. All right. This is the fourth chapter in your textbook, and in our classes, we have already begun learning this topic of chemical reactions. So, I'm going to revise the same portions and also, cover a few more new topics. In chemical reactions, in your class 7, you have studied the different characteristics of a chemical reaction, and also you have studied the conditions necessary for chemical reactions. All right. Now, chemical reactions are reactions that occur as a result of a chemical change. All right, as a result of a chemical change. Now, you must recall that chemical change is a change which results in formation of a completely new substance with new chemical properties, which has completely new chemical properties, and also which has a very different molecular composition as compared to its reactant. For example, the simplest example being, let's say if I react hydrogen gas with chlorine gas, it will form the molecule hydrogen chloride. It is formed in the form of a gas. All right. Now, hydrogen gas is a highly flammable gas, meaning it can catch fire much faster. So we usually call this an inflammable, which can burst into flames. Okay. And chlorine gas, on the other hand, is also a highly reactive gas, but it is not colorless. It has a greenish yellow color. It is a greenish yellow colored gas. Hydrogen gas is a colorless gas. Hydrogen chloride gas is also a colorless gas, but if you notice, the chemical composition of hydrogen chloride is very different from the composition of hydrogen and chlorine. All right. Not only that, hydrogen chloride shows completely new set of properties. Its properties, being chemical or even physical properties, are very different from that of hydrogen and chlorine molecules. All right. So a chemical change is a change which results in formation of a new product with new set of properties, which has a different chemical composition as compared to its reactants. All right. Now, chemical changes, how do you know that a chemical change has taken place? So the different ways to know that a chemical change has taken place are what we call its characteristics. All right. So there are few characteristics that we are going to touch up on. Okay. So the characteristics of a chemical change. During a chemical change, it's possible that, let's say I have A in a beaker. This is a very vague example, but just to explain, try and understand what I'm talking about here. So let's say I have two reactants A and B. I have mixed them together and it has formed the product C. All right. Now, how do you know that C has formed at all? Right. So you need to observe for certain characteristics. All right. What could the characteristics be? Firstly, a characteristic could be a change in color. All right. A change in color. So when you mix A and B together, all right, or when you react A and B together, that's the correct terminology, then it will form the product C. And do you see any change in color of the reactant from the color of the product? Yes or no? That is one of the characteristics that you have to look out for. The second characteristic is evolution of gas. All right, evolution of gas. When the reaction is taking place, is there some kind of effervescence or bubbling or some kind of fumes being formed or some kind of gas being formed at the end of the reaction? That also lets you know that a chemical change has taken place. All right. Thirdly, there could be a change in state. All right. Change in state. For example, A, B could be gases and C could be a liquid. So is C a liquid or is it a solid? So that change in state could also be one of the characteristics that you may observe. All right. Fourth is formation of precipitate. Now here it is important to understand the word. What does precipitate mean? Precipitate is an insoluble solid. Okay, insoluble in what? Insoluble in water. I'm talking about water because most of the chemical reactions that you are going to study at this level are reactions that are carried out in water. So all of the reactions are solution-based reactions. If I have a solution of A reacting with a solution of B, then on reacting together, maybe there is some kind of solid residue formed, right, in C. That solid residue, that insoluble, which does not dissolve in the liquid, does not dissolve in water over here. So that insoluble residue is what we call a precipitate. Okay, 1 second. Precipitate. Okay, now that is the fourth characteristic. Is there something insoluble forming at the end of the reaction or not? All right. Lastly, and one of the most common, and you have studied reactions based on this, common change that you observe is change in temperature of the final product. If you hold the beaker, at the end of the reaction, does the beaker feel hot or does it feel cold? If the beaker feels hot, it signifies that at the end of the reaction, there's heat energy being released, right? However, if the beaker feels cold, that suggests that heat energy was absorbed, right? That's why during the reaction, that's why C has decreased. That's why the product's energy or the temperature has decreased, all right? So those are what we would categorize under energy changes. So at the end of the reaction, there could either be change in energy, all right? There could either be change in energy in the sense energy could be either absorbed during the course of a reaction or energy could be released at the end of the reaction. Okay, so energy changes is again categorized into two kinds depending on what is happening. You either have an exothermic reaction, exo referring to out, thermic referring to heat energy, or you could have an endothermic reaction. So endo referring inside, heat energy is absorbed, and thermic again referring to heat energy. So energy changes could either be exothermic energy change or an endothermic. So depending on what happened in the course of the reaction, you have two different kinds of chemical reaction. So the characteristics that we are going to further study are the following 5. We are going to study reactions where we will observe change in color. There are going to be reactions where we would observe evolution of gas, change in state, formation of a precipitate, and we are also going to observe reactions where there is change in energy. I hope that is clear. Now moving on, let's take the first characteristic, change in color, right? So change in color. All right. Now, under these characteristics, there are several examples. There are also some examples mentioned in your textbook. All right. One such example is that of PB3O4. PB3O4 is actually commonly known as red lead oxide. All right. Now, this red lead oxide, it can break down into smaller molecules on heating. Okay, so on heating, red lead oxide can break down to form smaller molecules. What are those smaller molecules? It could form PbO and release oxygen gas. Okay, now again, it's important to note that PB3O4 is a solid, PbO is also a solid, and oxygen here is a gas. All right, now what is the color change that we observe? Just like the name suggests, lead oxide is red in color. On heating and forming lead monoxide, the name of this compound is lead monoxide. This lead monoxide is a yellow color solid. Okay, it's a yellow color solid. Clear? So here we would clearly see a change in color from red to yellow. Now the next example that we take is a reaction that takes place usually in the sky during lightning and thunderstorm. All right. So NO, this is in your textbook, it should be written as nitric oxide. All right. Now, nitric oxide reacts with oxygen in the air to form nitrogen dioxide. All right. Nitric oxide is a gas. Oxygen is also a gas. Nitrogen dioxide is also a gas. So when nitric oxide is reacting with oxygen, both of these reactant gases are colorless. All right. Oxygen is also a colorless gas. So how do you know that the reaction is complete? You will know that the reaction is complete if you see formation of a brown color fume at the end of the reaction. So nitrogen dioxide actually has a very, very distinct reddish brown color. Okay. So at the end of the reaction, if you notice a reddish brown color gas being formed, that's how you know that the reaction has come to a completion. All right. Nitric oxide, I do want you to make a note of it. Nitric oxide is also known as nitrogen monoxide, and nitrogen dioxide is called as it is. Okay. Now moving on to the next characteristic, we have, what was the next characteristic? It was evolution of gas. Okay. Now evolution of gas, evolution of gas. Evolution of gas is a characteristic that you observe when, let's say I take an example and then explain. So let's say I take zinc. Zinc is a metal, it is a solid. If I take granules of zinc, small granules of zinc, and add it to HCl, hydrogen chloride is a chemical substance, all right, which we will take in the form of aqueous solution. Hydrogen chloride is actually an acid, so we call this hydrochloric acid. AQ over here means that hydrochloric acid was prepared by dissolving hydrogen chloride in water. All right. So AQ refers to aqueous. AQ means aqueous. All right. And S means solid. So when I add these small pieces of zinc in a beaker consisting of HCl or in a test tube consisting of HCl, what happens is it leads to formation of a substance called ZnCl2, which is zinc chloride. All right. So a kind of salt is prepared, zinc chloride, and along with that, the moment you add zinc in the test tube, you should observe these tiny bubbles forming. All right. So let's say if I try to draw it, if this is a test tube and you've taken HCl and you've added small pieces of zinc, let's say zinc is actually a metal, so it should be steel. I don't have anything steel color, so let's say this is a zinc. Okay, you have added a piece of zinc inside. Okay, this is HCl and this is your zinc granule. The moment you add, zinc is going to immediately react with hydrochloric acid and you will see formation of these bubbles inside, right around zinc, where the reaction is actually taking place. So those bubbles are basically due to the formation of a certain gas. All right. And the gas which is formed is basically your hydrogen gas. All right. So at the end of the reaction, if you observe some kind of gas being formed, then that indicates the characteristic evolution of gas. Okay. Zinc chloride remains dissolved in water. So I had mentioned that HCl was dissolved in water. In the same test tube, you do have zinc chloride remaining dissolved in water. So we are going to mention its state as AQ, aqueous. All right. So this is the entire reaction with the name of the reactants and the products. All right. Along with their state symbols. So this is the example for evolution of gas. The next characteristic that we had seen, if we go back, the next characteristic was change in state, right? And change in state can be observed in the most common reaction that all of you know very well, all right? So change in state. Change in state can be observed in when you're trying to prepare water, right? So hydrogen gas reacts with oxygen gas, to form H2O. Now the water which is formed is actually present in liquid state at room temperature. All right, so this is the reaction. So you can clearly see that in the reactants, you have the reactants present in one state, which is the gaseous state, and in the product, you have the product present in a different state, which is liquid. Another very important reaction is the reaction where you see sublimation of ammonium chloride. So ammonium chloride, the formula is NH4Cl. It is a white color powdery substance. It's a solid. On heating ammonium chloride, you all know sublimation is the process by which a solid directly converts to gas, right? So ammonium chloride on heating, it does convert its state, but it does not form ammonium chloride as gas. What it does is there's a dissociation that takes place, and ammonium chloride breaks down to form two kinds of gases. It gives rise to ammonia and also hydrogen chloride gas. Okay, so these are the two gases which are formed at the end of the reaction. All right, let me just write down their names real quick. So this is your ammonium chloride. On heating, it breaks down to form ammonia. It has a very distinct pungent smell, ammonia and hydrogen chloride molecule in the form of gas. Okay. Now, the next characteristic that we are going to look at is formation of precipitate. Okay, formation of a precipitate. Now here, I'm going to take the example of, I'll take, let's say, AgNO3 and NaCl. Okay, AgNO3, if you recall your classes from language of chemistry, AgNO3 is silver nitrate. Okay, and NaCl is the most commonly used table salt. So sodium chloride, that is sodium chloride. All right. So here, there's one thing that is very important to know here, that AgNO3, you will prepare this, you'll take this salt, this is a salt, you'll take this salt by dissolving it in water. So what you're doing is basically preparing an aqueous solution. You're not taking the solid AgNO3. You're taking silver nitrate and then dissolving it in water. Then you will again take sodium chloride and dissolve it in water. So again, this is formation of precipitate is completely solution-based chemistry, reaction also. And here you are going to take the reactants in their aqueous state, meaning by dissolving the salts in the respective bakers in water. Now what happens is during formation of precipitate, AgNO3 reacts with NaCl to form AgCl and NaNO3, right? These are the two products which are formed at the end of the reaction. But how do you know which is insoluble, which is the precipitate? So for that, there are a couple of solubility rules that I will be mentioning when we study further about types of chemical reaction and we come across the same process of precipitation. For now, remember that NaNO3 which is formed is actually, it remains dissolved in water. All right. So what does not dissolve in water is our AgCl. That remains in the solution as a solid. In fact, it remains as a white color solid. So this solid, I will represent that this is the precipitate by drawing a downward arrow right next to the formula, like so. All right. So silver chloride is actually a white color precipitate which is formed. This is silver chloride, right? And this is sodium nitrate. So silver chloride is actually the insoluble substance which is formed at the end of this reaction, and that insoluble substance is what we call the precipitate. So this is our precipitate, and it's a white color precipitate. It's not necessary that all precipitates have the same color white. Different precipitates, depending on what metal is present or what metal ion is present in that precipitate, the color might vary. Okay, I hope this was clear. So when you're carrying out a reaction and you notice that there is something solid forming at the end of the reaction in your beaker, that suggests that there is a formation of precipitate. And that was your fourth characteristic out of the ones that we have seen. Lastly, you have the characteristic of change in energy. So energy changes is very important topic over here. So in energy changes, you will be studying about two kinds of energy changes, like I mentioned earlier. So energy could either be given out at the end of the reaction. Such reactions are called exothermic reactions. Or energy could be absorbed at the end of the reaction. So such reactions are called endothermic reactions. Okay, now an example of an exothermic reaction is when you prepare, let's say, hydrogen gas combining with chlorine gas to form HCl. Now remember that this reaction is actually a highly exothermic reaction, and this reaction can take place in the presence of sunlight. It is a highly exothermic reaction, meaning if there is a direct sunlight, then the reaction could even be explosive. So the necessary condition for the reaction is that there should be presence of diffused sunlight. We are going to discuss conditions in some time. So at the end of the reaction, heat energy is released. So I will represent heat energy in that manner. Okay. Next, the reaction for endothermic reaction, which I will talk about, is the reaction that takes place during thunderstorms. Nitrogen gas is a highly inert gas, does not readily react with substances. But during thunderstorms and lightning, due to the electrical discharge, it absorbs heat energy and it forms nitric oxide. So if the reaction is endothermic reaction, I will mention the heat energy on top of the arrow like so, because heat energy is absorbed. And if the reaction is an exothermic reaction and heat energy is released at the end of the reaction, then I will mention the heat in the products along with hydrogen chloride, which is our example over here. Is that clear, all of you? Okay, so I'll just summarize over here. So exothermic reaction, heat energy is evolved at the end of the reaction, and in endothermic reaction, heat energy is absorbed for the reaction to take place. Okay, I hope you have understood all the topics that has been taught in this session, and I'll see you again soon.